Hello everybody, welcome to session 10 of our Mastering the Basic Math Facts. We are now looking at multiplication by nines, and interestingly enough, a lot of times we think of nines as difficult, and yet there are a lot of connections for nines, and so for some kids, multiplication by 9 actually ends up being a little bit easier than some of the other facts, ironically, maybe it's like the one hard spelling word we end up focusing on so much that we end up knowing it better than the other. So as we flip over to our document camera real quick, just remembering where we've been and where we are headed. We are in the final set of 3 facts. We are now looking at our times 9 facts. We're going to use what we know about multiplying by 10 to help us find our nines, as well as just some good practice strategies for that. And then we will close up on our next 2 sessions with multiplying by 8 and multiplying by 7. So let's jump right on in here for today and think about, well, why nines now? We've done our zeros, our ones, our twos, our threes, our fours, our fives, our sixes, and our tens, right? So sevens, eights, and nines are what we're lacking at this point. So we know that sevens are probably the strangest of all the facts, or the furthest away from convenient or friendly numbers. So now that we have this good foundations with those zeros, ones, twos, fives, and tens, we like to move on to nines because nines are relatively friendly in the sense that they're close to tens. And so if we can practice and help kids make connections between what they know about their tens, they can generally grab onto their nines fairly quickly. There are so many patterns with the nines too, just visually and in objects, that they tend to be relatively friendly for kids. So this is a good place as we enter our last 3 facts to just pause and reflect. One of the questions that just personally I've struggled with is, this question of, well, why not just memorize the facts? Why wouldn't it be easier if we just memorized them? And I knew that wasn't true, and there was something, but I couldn't, for my own personal self, just settle on the fact, well, there's a good reason to conceptually understand these, but I need to be able to explain that. So this is one way that I think may make sense for some other folks. This is one way that it's helped me wrap my head around what a struggling math student really sees and thinks about when we give them the multiplication chart and we say, well, just memorize it. So what we've done is taken it out of context. So let's take the numbers out, but we're going to have the same rules, but let's just do it with letters. So this follows the same set of rules as our multiplication facts, except now all the numbers have been replaced with letters, right? So 0 still has the same property, which still, if there's nothing, it's nothing, right? But if you follow this through and you start to think about what we ask kids to do, we are in essence asking kids, if we're just saying memorize them and we're not giving them good conceptual experiences, what we're saying is, all right, well, you need to know your E facts, and E facts go like this: 0E, AO, AE, BO, BE, CO, CE, DO, AH, EO. All right, now by Friday, I want you to be able to tell me all those, and they need to make sense to you, and you need to be able to fill out a form, and you need to... That's really hard, right? And we said, but there's a lot of tricks, right? You're going to know that, anything A times anything is itself. So A times A is A, and A times B is B, and A times C is C, and it gets really confusing, right? Like for me, this is when I finally was able to understand where our kids are especially our struggling kids. If you're a great memorizer, you could memorize this chart too, and that would be fine, except when you forget what F times D is. Well, somebody who's a great memorizer has a really great memory. They might say, well, F times D is BD. Come on, you're supposed to just know that. I don't know if that's really fair for kids, right? So if we put the numbers back in, it might help a little bit, right? We can start to conceptualize, see where this all lays out. I don't know if that helps you, or if this is just something that for me made a lot of sense. So this is one that I've adapted some things some other authors have done, and tried to put this into something that I can share with others when we say, look, it's not easy, right? You have to have a concept You have to understand what something is if you're going to own it and if it's going to be easy. So speaking of that big picture, where are we now? Well, we're down to 4 unknowns at this point, right? Once we own our 9s, and that certainly is a process, but we would be down to the 4 unknowns. Really, we'd be down to 7 times 7, 7 times 8, 8 times 7, and 8 times 8. The rest of the chart with the commutative property would all be understood at this point for kids. And again, we know there's going to be some that people are stronger with and some that they struggle with. So kids are in different places at different times. Our big ideas remain fairly consistent, right? Knowing the patterns in our number system helps make it predictable. It also means that you have good number sense, right? It makes sense. Multiplication facts are connected, so if I know one set of facts, that can help me solve another one. So if I know my 10s, that's going to help me solve my 9s. And then we know the commutative property shows up again and again. And by the time we reach our 9s facts, there's really only 3 new 9s, and those would be 9 times 7, 9 times 8, and 9 times 9. The questions, just as we've done with every other section, we would be looking at, well, how are 9s and 10s related? What patterns do we notice in our 9s? And when we're multiplying by 9, do we immediately know the tens digit of the product? So if I'm taking 9 times 8, do I immediately know that tens digit is a 7, and why? And then which facts of the 9s do we already know? So the text for this section is a fairly comfortable, fairly familiar text, and that is Cloudy with a Chance of Meatballs. Probably a lot of our students know Cloudy with a Chance of Meatballs, not by the book, although some of them would, but a lot of them are going to know it because of the movie, right? So it's using this as an intriguing context for multiplying by 9. So let's go ahead and jump in here with our question being, what might it be like if it rained meatballs? Just a discussion kind of thing for kids. What other kind of foods might fall from the sky, right? And we're going to ask kids to listen for some very unusual weather in a very unusual town. And if you've seen the movie, or if you have a lot of kids who have seen the movie, you might want to encourage them to do a comparison contrast. What's the same? What's different? So let's jump over here to our story and go ahead and get started. So let me zoom out here just a little bit. So this is Cloudy with a Chance of Meatballs by Judy Barrett. And again, this is probably a fairly familiar text for many of you. We were all sitting around the big kitchen table. It was Saturday morning and it was pancake morning. Mom was squeezing oranges for juice. Henry and I were betting on how many pancakes we could each eat, and Grandpa was doing the flipping. Seconds later, something flew through the window, through the air, and headed toward the kitchen ceiling, and landed right on Henry. After we realized that the flying object was a pancake, we all laughed, even Grandpa. Breakfast continued quite uneventfully. All the other pancakes landed in the pan, and all of them were eaten, even the one that had landed on Henry. That night, touched off by the pancake incident at breakfast, Grandpa told us the best tall-tale bedtime story he'd ever told. Across an ocean over lots of huge, bumpy mountains, across 3 hot deserts and 1 smaller ocean, there lay a tiny town of Chew and Swallow. In most ways, it was very much like any tiny town. It had a main street lined with stores, houses with trees and gardens around them, a schoolhouse, about 300 people, and some assorted cats and dogs. But there were no food stores in the town of Chew and Swallow. They didn't need any. The sky supplied all the food they could possibly want. The only thing that was really different about Chew and Swallow was its weather. It came 3 times a day, at breakfast, lunch, and dinner. Everything that everyone ate came from the sky. Whatever the weather served, that was what they ate. But it never rained rain, it never snowed snow, and it never blew just wind. It rained things like soup and juice. It snowed mashed potatoes and green peas, and sometimes the wind blew in storms of hamburgers. The people could watch the weather report on television in the morning, and they would hear a prediction for the next day's food. When the townspeople went outside, they carried their plates, cups, glasses, forks, spoons, knives, and napkins with them, and that way they would always be prepared for any kind of weather. If there were leftovers, and there usually were, the people took them home and put them in their refrigerators just in case they got hungry between meals. The menu varied. By the time they woke up in the morning, the breakfast was coming down. After a brief shower of orange juice, low clouds, sunny side up eggs moved in, followed by pieces of toast. Butter and jelly sprinkled down for the toast, and most of the time it rained milk afterwards. For lunch one day, frankfurters, already in their rolls, blew in from the northwest at about 5 miles an hour. There were mustard clouds nearby, and the wind shifted to the east and brought in baked beans. A drizzle of soda finished off the meal. Dinner one night consisted of lamb chops, becoming heavy at times with an occasional ketchup. Periods of peas and baked potatoes were followed by gradual clearing, with a wonderful jello setting in the west. The sanitation department of Chew and Swallow had a rather unusual job for a sanitation department. It had to remove the food that fell on the houses and sidewalks and lawns. The workers cleaned things up after every meal and fed the dogs and cats. Then they emptied some of it into the surrounding oceans for the fish and turtles and whales to eat. The rest of the food was put back into the earth so the soil would be rich for people's flower gardens. Life for the townspeople was delicious, until the weather took a turn for the worse. One day there was nothing but gorgonzola cheese all day. The next day there was only broccoli, overcooked. And the next day there were Brussels sprouts and peanut butter with mayonnaise. Another day there was pea soup fog. No one could see where they were going, and they could barely find the meal that got stuck in the fog. The food was getting larger and larger, and so were the portions. The people were getting frightened. Violent storms blew up frequently. Awful things were happening. One Tuesday there was a hurricane of bread and rolls all day long and into the night. There were soft rolls and hard rolls, some with seeds and some without. There was white bread and rye and whole wheat toast. Most of it was larger than they had ever seen bread and rolls be before. It was a terrible day. Everyone had to stay indoors. Roofs were damaged and the sanitation department was beside itself. The mess took the workers 4 days to clean up, and the sea was full of floating rolls. To help people out, the people piled up as much bread as they could in their backyards. The birds picked at it a bit, but it stayed there and just got staler and staler. There was a storm of pancakes one morning and a downpour of maple syrup that nearly flooded the town. A huge pancake covered the school. No one could get it off because of its weight, and they had to close school. Lunch one day brought 15-inch drifts of cream, cheese, and jelly sandwiches. Everyone ate themselves sick, and the day ended with a stomachache. There was an awful salt and pepper wind accompanied by an even worse tomato tornado. People were sneezing themselves silly and running in to avoid the tomatoes. The town was a mess, and there were seeds and pulp everywhere. The sanitation department just gave up. The job was too big. Everyone feared for their lives. They couldn't go outside most of the time. Many houses had been badly damaged by giant meatballs. Stores were boarded up, and there was no more school for the children. So a decision was made to abandon the town of Chew and Swallow. It was a matter of survival. The people glued together the giant pieces of stale bread sandwich style with peanut butter, and they took their absolute necessities with them and set sail on rafts for a new land. After being afloat for a week, they finally reached a small coastal town which welcomed them. The bread had held up surprisingly well enough for them to build temporary houses for themselves out of it. The children began school again, and all the adults tried to find places for themselves in the new land. The biggest change they had to make was getting used to buying food at a supermarket. They found it odd that the food was kept on shelves, packaged in boxes, cans, and bottles. Meat that had to be cooked was kept in large refrigerators. Nothing came down from the sky except rain and snow. The clouds above their heads were not made out of fried eggs. No one ever got hit by a hamburger again. And no one dared to go back to Chew and Swallow to find out what had happened. They were too afraid. Henry and I were awake until the very end of Grandpa's story. I remember his good-night kiss. The next morning we woke up to see snow falling outside our window. We ran downstairs for breakfast and ate it a little faster than usual so we could go sledding with Grandpa. It's funny, but even as we were sliding down the hill, we thought we saw a giant pat of butter at the top, and we could almost smell mashed potatoes. The end. So definitely a little different than than what kids have probably heard with or that they saw in the movie. So that would be one place to take kids. But another place is that we remember that the real purpose of these stories is to build a context for understanding multiplication and Obviously, we're not trying to understand multiplication by 6, we're understanding multiplication by 9, so apologize for leaving that on the slide here. So as we're looking at understanding our 9s, we're asking kids to think about things like, well, let's have partners test some predictions, right? So let's discuss how many meatballs, if you had 8 people and they collected 9 meatballs, as compared to 10 meatballs. So we have students draw it out. Let's do some paper plates. Let's draw them out, and let's see how this works out. So if they model, again, 8 people, right, and they have 9 meatballs, so, and then we have 10 meatballs for those 8 people. So what's the difference if I have 9 meatballs or if I have 10 meatballs? Once they share their findings and we have the plates around the room, so we got these plates. They all have 9 meatballs and 10 meatballs, and so we're going to invite 8 of the folks up to the front of the room who have 9 meatballs on their plate. And again, these are just their little drawings of their 9 meatballs. And so, okay, so if I have 8 kids in the front of the room and they each have 9 meatballs, well, how many meatballs is that, right? And let's compare that to 8 groups of 10 meatballs, because we should probably know, or most of our kids probably know, that 8 groups of 10 meatballs is 80, right? And so what about 8 groups of 9 meatballs? Do they notice that that's 8 less? So if they get 72 and they compare that to 80, are they recognizing, well, that's 8 less? Well, where is that 8? That's the number of groups that came up, right? So in order for kids to start to recognize this, we're going to have to structure it for them. We're going to have to give them some chances to look at multiple scenarios, right? So let's again look at building a context for understanding this by 9. And again, my apologies here for having 6 on there. So once they've read, we're going to have kids work with their partners. And again, they've just seen their friends come up to the front and look at the connection between 9s and 10s. Kids are going to look at the list of 9s facts and then the list of 10s with the same thing. So we've got our chart over here. So if I have one person, right, and they have 9 meatballs on their chart, then they are going to have 9 total meatballs. And if there are 2 people with 9, then that's going to be 18, right? And then we're going to get to 27 and 36. But over here, if I have one person and they have 10 meatballs on their plate, they're going to have 10 meatballs. Well, 10 is one more than 9. That's interesting. And if they have 10 meatballs on their plate, there's 2 people, then that's going to give me 20. Well, 20 is 2 more than 18, and 30 is going to be 3 more than 27. So then we're asking them to notice, what do they notice about the connection, and see if they can start owning a little bit of this information for themselves. Can they predict or explain why 9 plates of 9 meatballs is 81? Do they get that 9 plates of 10 meatballs would be 90? And so this is going to be 9 less. That's where we obviously want kids to get to, but we know we're going to have to give them multiple experiences, right? So as we continue to look for patterns, let's try one of the charts that we've used with some of our earlier facts. So what do our 9s facts look like? And even if kids just have to add these up to get 9, 18, 27, 36, some are going to see that as counting by 9. Some of it are going to be skip counting. Some of them might do times 10 less 1. That would be awesome. If kids recognize that and they were using that as their own. Some kids are going to notice that the multiples of 9 all add up to 9. The digits all add up to 9. Some are going to recognize that some of them are reverses of each other, like 45 and 54. Some are going to recognize that as the 10's digit grows by 1, the 1's digit decreases by 1. So we go 1, 8 for 18, and then 2, 7 for 27, and 3, 6, and then 4, 5, and 5, 4, and that pattern that they'll see there. And again, those are all good. A lot of times this is when somebody wants to go to the finger tricks, right, and say, well, if I have 9 times 2, then I put down the second finger, and that gives me my answer, right, of 18. The problem with this, if you probably are already thinking it, is this really doesn't have any, it's a nice trick, right, that I can see this is 1, and then these 8 make the 18. It's a nice trick, and it works for times 9, but there's no real conceptual understanding there. So if I forget something and I say, well, let me think, 9 times 2, do I keep the 2 and I bring down this thing? All of a sudden, I can get the wrong answer if I forget the trick. Right? So we want to make sure we're grounded in the real math of knowing our facts. and that tricks like using your finger and things, we have to remember those fall apart when I forget how they work. So some kids are going to do that. Some parents are going to show their kids that. By all means, if they want to show them that, then that's certainly fine. But in terms of education, I think we want to keep kids focused on the real math there. So these are the kind of patterns we want kids to start to realize that exist here. So as kids write them down, we're going to ask them to come up with their patterns, and then ask them to reflect, right? So based on your observation, if you forgot a times 9 fact, what will be your trigger? What would help you remember how those facts really work? So we recognize some kids are going to need more practice than others. So let's think about some other ways we can give kids practice. One is by looking at common errors, right? So we can give kids a list, right, of things like 9 times 6, 9 times 9, 9 times 7, 9 times 3, and say, okay, so which ones of these make sense? And making sense is not, that's number sense, right? Is saying, okay, so if I understand that 5 times 10 is 50, then 5 times 9 has to be less than that, right? So if I see something like 9 times 6 is 45, well, 10 times 6 would be 60. So is that close enough to 60 if I have, that one may or may not trigger me. 9 times 9, well, let me think, 9 times 10 would be 90. Well, that's 9 less, that's 81, that works. 9 times 7 is 63. 9 times 3 is 18. Well, again, is it close enough to that? So giving kids ones that are close but not right, some that are way off, will definitely trigger some responses from kids. But the important thing is not that we can explain it to them as to why could it be right or is it totally wrong. The important thing is that they're able to verbalize which ones make sense and which ones do not. Another way is to use some of our manipulatives, right? So we can have kids take things like 10 rows of Unifix cubes, right? They can, and ask kids to skip count to find, like, so if you give them 6 rows of Unifix cubes and say, all right, well, let's take a look at 6 rows of Unifix cubes here. So let me switch over to our document camera for a minute. So if I have 6 rows of Unifix cubes here, and I'm asking myself, okay, so what is, this would be 6 groups of 10, so I might know that 6 times 10 is 60, or I might need to explore that. Well, now I can definitely write it out, right? I've got 6 times 10 is going to give me 60, but what happens when I take 1 away from each of these, right? So maybe I'm not interested in my 10s anymore, but I'm interested in my 9s, so let's change each of these to be a 9, right? And possibly keeping them together like this, right? So they recognize that this is 9 and 1 more still makes the 10, right? I still have the 10 there, but I'm also thinking about, well, if this was 10, 20, 30, 40, 50, 60, what have I taken away here? I've got 60 less 1, 2, 3, 4, 5, 6. 60 less 6, right? Well, that would give me 54. And I could count them up, right? 9, 18, 27, 36, 45, 54. Some are going to have to do much more complicated counting. But what I want to start to make sense of is that this is my 9's facts are 10s, right? But 1 less. So if I can picture it that way, then when I do 9 times 7, so, oh, well, that'd be like 10 times 7. I know that's 70. That's going to give me 70. And it's not going to be less 6, right? It's going to be less 7. So 70 less 7, or 7 less than 70, oh, that's 63. So now I can use that no matter what my total is, right? If it's 4, I can say, well, that would be 40 less the 4. So that's going to be 36. So again, giving kids a strategy that will work and that I don't have to just remember. I can actually go back and physically rebuild it if I need to. So we'd want kids to repeat that with other 10s chains, just like we just did, and to do it repeatedly, especially for our struggling kids. A nice way for kids to show us what they know is to give them a scenario, right? And kids a lot of times will like to share how they're solving something if they think they're helping someone else. So if you have a friend who's struggling with their nines facts, what would you tell them to help them? What would be your strategies? For making things automatic, we've got our fact cards again. Again, remembering that we aren't starting with the fact cards. We're starting with building the concept and then moving to building the fact cards. So the ones you see here on the screen are the division ones. You certainly have all the multiplying just with the nines, the mixed review of 9 times all the other facts. Remembering that for some kids it's going to be important to do individual checkups, and for other kids it's okay to do them all at once. So another game, or another activity I should say, that we can play is called condition. So kids are going to pull a card from the top of a deck, and they are going to multiply the number by 9, right? So they're just going to pull, if they pull out a 4, they're going to multiply that by 9. So 9 times 4, that's 36. And they flip over a condition card. So if that product, so if mine was 36 and I flip the one over that says less than 80, well, that works, right? Because 36 is less than 80. And then I return the number to the deck, but I get to keep the condition card. If it doesn't match the condition, then I flip it back over. So there's a little bit of the concentration game going on here, which is kind of fun for kids. 9 cross, again, this could also be used for just focusing on our nines facts, but if we shuffle 2 sets of our number cards, so we've got these number cards twice, and we're shuffling them, put them in a pile face down. You're going to pull out a number, multiply it by 9, and then put it in the space in the board. So if I pull the 7, then I'm going to put, well, 9 times 7 is 63, so that's going to fit over here, right? 9 times 7 is 63, or I could put it there, but I can only put it in one place at a time. So the goal is obviously to fill up my board. Highs and lows, again, multiplying by 9 fact cards, we're going to shuffle them, we're going to put them face down. So again, you have all these in the digital downloads if you choose to take this text. The interesting part here is, so I'm going to flip over a card, I'm going to say, well, 9 times 2 is 18, and then I've got to predict if the next product is going to be higher or lower. So there's a little bit of chance playing in here, right? So I've got these laid out. If it's correct, then I get to take the next face down card, and the goal is to correctly predict all the cards. Now, in the text, they say if the prediction's incorrect, you're going to shuffle them up and lay them out. I would almost prefer to just lay them all out in a row, and as I start to listen to the other people that I'm sitting with answer theirs. So if I got the first 3 right and then I missed the 4th one, well, then the next person I think starts with that first one again, and now they know the first 3, or if they've been listening. So it encourages that I'm listening to you, and now I'm getting better because I'm listening to you, and I get to move further down along the game. So definitely different ways you could play this. Play different ways in different days, which makes it fun for kids. As we look to connect to division, this is not the right slide. There we go. But so let me jump over that one. Sorry, that was from our times 6 facts. So when we get into monitoring progress, I think it's good. It's always good to connect back to writing, as we did before when you're explaining something to someone else, but also writing my own sets of rules, right? So if I can't remember a whatever fact, whether it's 9 times something or something else, this is what I do. Or a good way that I think about the facts is these make nice little multiplication, my classroom multiplication book kind of things for the whole class to compile. Things that are easy, things that are hard to multiply by, and why. If a friend is having a tough time learning whatever facts, I'd help them remember by. Always remembering we have our triangle fact cards is another way to connect to division. So remember the circled one is the product. So if I put my finger over one of the non-circled ones, again, I'll cut these apart. Put my finger over the non-circled one, then I know the product, I know the quotient, and I know one of the other factors, so I can then have to figure out what the third one is. And finally, minding our P's and Q's, not our pints and quarts in this case, but our products and our quotients. So we're going to spread out multiplication and division facts all face down. Players are going to flip over their cards to make a match, right? So similar to concentration, except now I've got to state the product or the quotient for the first one I flip over, and if it's correct, then I'm flipping over one of the others, and the idea is to match the division statement with the multiplication statement. So I've got to know the answer, and then I can try to find the match for it. As we shared with the last one, again, no assignment outside in this one. Next up, we're going to go to multiplying by 8. We'll have one final assignment as we finish these final 3. So this takes us through our 9s facts. We'll then hear our 8s and our 7s. We say thank you for your time, and we look forward to seeing you in our next session.